So far, we've learned how to solve simple equations, right? Where we're given an equation with, we're given an equation with, single term on this side, or a single term on this side, or multiple terms on this side, and multiple terms on this side. Where we're able to take the rules that we learned for addition and subtraction, multiplication and division, exponents and radicals, and using the sort of the shortcut of cross multiplication, right, where we can go take the denominator from this side, kick it up to the numerator there, denominator here, kick it up to the numerator there. So we were given equations, simple equations, and we took the rules that we learned of how to move around an equal sign, where if you want to get rid of something here, you do the opposite to it being done here, so it goes over here, so you do it on both sides. And whatever you do on one side of the equation, you got it to the other side, balance the equation, right? So basically so far we've learned how to solve simple equations by using the rules that we learned of how to move around an equation, right? So we're given an equation here, we use these rules, we crunch as far as we can go, and we're able to get x equal to a number. Right? And that was us solving a simple equation. Now, in mathematics, all equations are simple equations where we're able to isolate the x variable just using these simple rules. What we get is, more complicated equations where basically equations representing functions, they model more complex situations, more complex systems than just simple equations like this. And to be able to solve those types of equations, we're going to have to introduce new rules. Okay? We're going to have to introduce new rules here in addition to these rules that we have to be able to crunch more complex equations than just simple equations to get to the answer. And usually more complex equations than just simple equations have not just one x answer. Sometimes we're going to get multiple x solutions. Okay? There could be multiple x solutions. It could be one, it could be none, it could be 3, it could be 10 different solutions for the same equation. And if you remember, we talked about this, where solutions are basically where the function crosses the x-axis, where y is equal to 0. So a complex function, it would make sense, right? If a function is doing all types of weird curves and asymptotes, it'll probably cross the x-axis more than just once or more than just twice. It might cross it multiple times, right? So what we're going to do now is talk about one other type of equations that comes up right after simple equations usually, which are called quadratic equations. Now, I did a couple of quadratic equations, and we've talked about it a little bit, but we're going to delve into it a lot more and figure out how to solve for quadratic equations. And what we're going to do is introduce 5 new techniques, really. It's two groups of techniques. One of them is called factoring, and there's just 4 different types of factoring for equations that we can factor, quadratic equations that we can factor. And the other one is a formula which is called a quadratic formula for equations that we cannot factor. So what we're going to do, basically we're going to acquire new powers in addition to these ones to be able to crunch more complex equations. So these new powers are factoring, and the quadratic equation. Well, the quadratic formula, sorry. The quadratic formula. And quadratic formula gives us the factors, which are the roots, the zeros, the x-intercepts, for stuff that we can't factor straight up. So, in addition to these guys, we're going to learn these new tools and be able to crunch more complicated equations than just simple equations where we only get one x solution, right? We're going to start talking about multiple x solutions and more complicated equations. And those the first place that we're going to go to for those complicated equations are quadratic functions or quadratic equations for now. Later on, we're going to start calling them quadratic functions because solving equations, as we talked about before, you're basically setting y equal to 0 and solving for the x-intercepts. Okay? And quadratic functions take the form of... Now these equations are called quadratic equations where a does not equal 0. Okay. Because if a is equal to 0, this guy disappears, and we're left with just a linear equation, linear function basically, and we know how to solve these equations, right? We move the c over, it becomes minus c, divide by b, so we've got x is equal to negative c over b. That's easy to solve, just using, these rules, right? Over here, we can't just simply solve for this equation using these rules that we talked about, in the previous videos. We need to introduce factoring and the quadratic formula for stuff that can't factor straight up. And this formula is going to come in. This formula you're going to use multiple times. This is the only formula that I remembered years after graduating high school because I ended up using it so much. And all you do, these numbers here, these letters here, represent the coefficients here, these constants here. All you do, whenever you get a quadratic equation, you put it into this form and plug in those numbers for a, b, and c, and just solve for it, and that gives you your x-intercepts. Now for quadratic functions, for quadratic equations, we're not going to have 3 solutions. For quadratic equations, you're going to have at most 2 solutions, sometimes only 1 solution, sometimes no solution. Because quadratic functions, and we talked about this a little bit, represent parabolas, and parabolas are just things like this, and they have this form to them. So let's get rid of this stuff and talk about the quadratic equation a little bit.